because today we have a very wonderful person in our midst, our very own brother and friend, and a software engineer in the name Mr. Shihurum Ikechukwu is here in our midst to Ikechukwu, you are highly welcome.
You have introduced me like a new wrestler.
Yeah. So moving on, today, what we have today is a very vital topic, very vital topic, JWT in the Spring Boot application. And we all know how important this very technology is in modern day application security, making it stateless and the rest of them. I guess Ikechukwu has more and a lot to give us today, and it's going to be a very super exciting section. So if you are here, I count you lucky, and I will say a very big welcome to everyone present. And at this moment, I will have no option than to welcome Mr. Ikechukwu to take the floor. Mr. Ikechukwu, feel free to take the floor.
Ikechukwu, thank you very much. Yeah, I will throw the cap. There you go. Thank you very much for having me this evening. Okay, so let me go ahead to just share my screen. I think 5 minutes of our time already gone. So let's see what we can do. If there's a chance today, we could do a demo, or I could just share a previous one that I've actually done. So let's see how fast we can actually get this done. It's 1 hour. So can you see my screen? Can I see my screen?
Yeah, sure, I can.
Okay, so let's get that. So okay, so our topic today would be JWT Security Model. We are going to talk about the concepts that surround JWT and look at how to actually implement it in Spring Boot, how it works. Well, Spring Boot has actually changed a lot. So we're going to actually cover we're going to cover a lot of the theoretical aspects of JWT before we move into the practical implementation in Spring Boot. We're going to try and understand why JWT, what it is, how does it look like, and try to break it down to the best as we can. The kind of dependency you need for your JWT in your Spring Boot. We're going to talk about, we're going to look at the whole authentication flow in Spring Boot. That's the agenda for today. So normally a user would sign in and then they'll get the session ID, and you map the session ID to the identity in a database or in a cache in a Redis or whatever in a data store. But this software isn't really more of like a single server. But in scale, sessions aren't really working out, because with sessions, we need a centralized data store, because you need to keep track of users create data stores or nodes across, and then you have to sync that session ID across those nodes, which distributed system is hard enough. Doing it at that scale would actually be very difficult. So mandatory identity verification, you have to verify each request. That means for every kind of identity, you have to hit up your database. Session-based paradigm, so you have to actually store on memory database. So imagine a period whereby you have a lot of users. It means that your data store that is handling that your session will actually be hot. scalability issues. So, like I just said, with the microservices and distributed systems that we're building now, these sessions were not really working. And statefulness. So nodes have to synchronize data between themselves. Now we have microservices, and different kind of services can stand alone. So if we are using a stateful traditional method, each of those services would kind of have to keep track of the user in a centralized store, which wasn't really working out. So scaling becomes very, very difficult when we use it in distributed systems. It was a very big bottleneck. So this is where JWT actually introduces the stateless model. But what is JWT? So JWT is JSON Web Token, or that is JavaScript object notation. That is the web token for it. It's just a string that's basically before you are encoded that has 3 sections. The main purpose of JWT is to actually contain claims or to transfer information between 2 parties. That is actually what JWT is about. So JSON is actually a very good format, a very printable format. So you need to create something that is more. They wanted to use it to create something compact, so we can use to share across the web, share claims and information across the web. What are the characteristics of JWT? It is compact, meaning that within that token, you have every single thing you need to identify a user. You have every single thing as an identity. So you could look at JWT as kind of like a key to use and enter a house, while session as your gateman. So if I had a house and I had the gateman in front of my gate, the gateman will actually have to maybe call me and tell me, oh, someone is at my door, someone else, can I let him in? So what happens in a day where my data store for me, I am not around? It means that the visitor won't be able to enter my house. But if I have a key, or I have a card I can give my visitor, I could tell him, anytime you want to enter this house, since I know you and I trust you, this key is enough for you to go anywhere. Take this key. That's how JWT actually is. So that's a very simple way I can actually break it down. So, and it is stateless, meaning that, since I said every single thing you need to identify a user or to authorize the user or to authenticate them is within that token. It is very perfect for most of the modern architectures we are beginning today. It is very friendly. It's small and very friendly, transfer friendly. So because JWT is base 64 URL encoded, I don't know whether I should get to base 64, but base 64 is a way of taking binary and converting it to a text format. The 64 URL is more of, you know how you add a space to your browser tab, it turns into %20. So spaces and tabs and there are some characters that actually break the internet. So the 64 URL encodes it in a format that makes it very easy to send. And your JWTs can get big, but most of the time they're not that big. So it can fit into your headers, your cookies, your query params, and we're going to see how they all work. So use it as a way to transfer claims. We're going to find out what claims are. We're going to actually go into it. So this is just an example of, I don't know whether can you guys see it, the JWT on the screen. Hello?
Yeah, sure. I can see your screen.
So yeah, there's the JWT on the screen. So this is just actually this. This might actually look like gibberish, but this actually is just an encoding of JSON. That is what JWT is. It's JSON that have gone through a function that puts it into this. And we're going to look into the structure. So let's see it's practical. So how does JWT fit into this world? We use it for these main operations. Authentication, that is to identify who the user is. Authorization, what they can access. If you are someone who have dealt with or at least even if you have come across it in a way, you will actually see this. Federated identity. So this is actually a very important one, whereby I'm not an expert in building enterprise level applications, but federated identity, I have seen it in, I think when I was in school, I wanted to access a library or something where I had to register with the Nigerian Library Institute, and then because with that login I had from that Nigerian Library Institute or something, I was able to gain access to other university libraries around the country, other universities, the schools. So So if we have to implement that kind of architecture, you actually need JWT. Your sessions can't do it. So client-side sessions, JWTs are technically sessions, but they are just not stateful. We don't need to store anything on the server. We can trust the JWT that it is compact and has everything we need to verify it. Client-side secrets. JWT is not just for your authentication or authorization. You can also use to hide. You can also use to hide claims. So even though JWT most of the time can be seen by everyone, if you decode the JWT, you can see it. But JWT is actually has encryption that comes with it. It has an encryption algorithm that you can actually use to encrypt the entire JWT that no one can actually read it. This is actually more complex, and most of our systems don't really rely on encryption. It's mainly signing. You might also see that here, but let's keep going. So real world cases of JWT, even if you haven't used it here, these are some places that if you venture into, you're going to obviously you need to use JWT. RESTful APIs, it is almost the default now for the developer. And anytime they're creating APIs, they just default to JWTs because of its statelessness. You don't have to keep track of sessions, you don't have to have that whole bottleneck. You don't have to care about all those the overhead that comes with keeping track of sessions. Microservice ecosystem. We have architectures now where when you're interacting with a site or with a backend, it's not usually one service anymore, it's always multiple. If you go through your OP or your Paystack or whatever, you see that your single payment goes through a lot of people. It might even go past the company that you're even the company's website that you're actually interacting with. It goes to another, does something, comes back. So propagating across these services, we need this token that can actually handle it, a token that is compact and can be actually verified and identified within itself. Statelessness. Mobile applications. For the Android devs, I don't really do much Android. I'm guessing that they use mobile applications, they use JWT too. Single page applications. The time I started with React and the little I've done with Angular, or the most I see online, almost everybody uses JWT. So yeah, the web developer, you're going to be calling RESTful APIs in your single page applications. You cannot escape it. So a little bit of history. So no matter whatever we are learning or whatever we are looking at, we also have to be able to understand that it didn't just appear out of thin air. It's not just magic. We have the JSON object signing and encryption group. So these people actually monitor the spec of the JWT space. They are called Jose or Jose. So I'm not really sure. Man, Englishman. So Jose is basically so in most of the software things that we have more software ecosystem. We have a set of people that actually handle specs of various different parts of think OSI, even web standard, even JavaScript standard. JavaScript actually have a spec of people that JavaScript even have a spec of people that handle it. So in 2011, the group team came together to actually create a spec for JavaScript for JWT. So JW, they wanted to create something that had integrity within itself. So JSON was actually used everywhere. It was a payload that was used everywhere. So they needed to use that JSON and convert it in a way that it will have integrity within itself. And it led to some specs being formed. JWT, JSON Web Token, JWS. JWS is JW signature. That is JSON Web Signature. So a signed JWT is called JWS, or you can call it JWS. JWE is for encryption. JWK is to represent JSON Web Keys. We're going to see a little bit more about secret keys and the rest. So the main authors behind this spec are Mike Jones, Mark Sakimura, John Bradley. I just wanted to add this here so that we see that it's actually a project that people actually took up and did. JWT is not something set from the heavens. Someone actually sat down and they did it, and it has taken over the web. It's almost everywhere now. So let's look into the structure of JWT. So JWT, when we talk about claims, so claims are JWT is literally just JSON. You can see in the image, just JSON. If you're someone that is familiar with you have seen the JavaScript ecosystem, you can see that it's just JSON. That is all JWT is. So normally in JSON, you could call this your key and this your value, but in the terminology of JWT, you call them claims. So claims are name of this subject is, I'm claiming that it is fortunate. I am claiming that this token will expire at this time. I am claiming. So anytime you hear claims, kind of revert your mind to JWTs. So JWTs is just like in the definition, it's just a 64 URL encoded JSON that is just three concatenated segments. So we have the header, the payload, and signature. We're going to look into the header. The header just contains metadata of how the token is secured. You don't really concern yourself with the headers. The people that concern themselves with the headers might be the libraries that you're probably going to be using. So it contains the algorithm and the type. I think it can contain more, but the algorithm is basically what you use for a cryptographic hash of the token. So like I said, the token has every single thing you need to properly validate it. So attached to it, we're going to look at the signature, which is the third part. The algorithm will tell you which kind of signature was used to actually create that signature and how you can use it to verify it. So it's very important for the library that this algorithm, this alg is actually there. And type, like I said, JWT is compact. So they try to keep it to 3-letter words because they don't really want the JWT to explode and be very big. So we're going to look at the importance, but this is just something to take note. That is, they could actually have written a type or algorithm, but the more you put into JWT, the more that they get bigger. So payload, claims is just the data that is passed in the JWT. Like I said, it's an assertion made on the user. So parties want to exchange information. They exchange claims. That is all JWT is. There are two types, or there are three. Some will say two, some will say three. I just put it to registered claims and custom claims. Registered claims are the ones that are part of the spec, the standard fields. We have the ISS, which is the issuer, the person who gave out the token. The sub, the subject, the person who the token relates to. We have the expiration date, that is when it's expiring, and issue that when it's issued. Custom claims can be public or private. So private is actually you, but public is IANN, which is another organization or standard, can reserve a claim for you. So if your company, that is usually a claim you use, and you want it to be marked in stone or part of the spec, you can register with them, and then that you own a claim. You can actually own a claim if you want, but it's not really necessary. These are the things you can store in your custom, your user rules. If you are using a tenant system, the tenant ID, some flags and some metadata. Maybe admin true, admin false. So JWT signature. This is how you know that it is valid. The signature ensures integrity. But the signature is actually very easy. It's just you concatenate the first string and the second string, you join them together, and then you pass it through a hashing algorithm or an encryption algorithm. So there are mainly two that you're going to be seeing, or three, sorry. The secret key one, which is a H mark, and the private key, RSA, ECDS, yes, ESA. So the secret key H mark is a symmetric key, symmetric encryption. Symmetric encryption, it means you're only using one key. But private keys, using private key and public key is asymmetric, meaning that there are two keys. When you are using SSH in your GitHub, when you are, I think, on your browser, your HTTPS, most of the security protocols that we use nowadays are actually built around RSA. We still use HMark for some. I think HMark, if you are doing payment and stuff with Paystack or some interswitch or some payment providers in Nigeria, you come across HMark to identify whether the request came from the right place. So we actually, if you are in your software journey, you come across this. So JWT uses them. Why do we use signature? So that we know if it is tampered with. We don't want our JWT to be modified without our knowledge. We don't want anything to change. So, like I said, if you come down here, you could see that a JWS is just a JWT that is signed, but is not encrypted. It has integrity and authenticity, but it is visible. Anybody can see what is in the token. JWT is encrypted and is more confidential. It is more complex to implement, but nobody will see what is inside. So before I actually want to I'll move over to a browser so that we could actually see JWT in action a little bit. But this is just the generation. So JWT is not magic. It's just we have our header, we convert it to JSON. We have our payload, we convert it to JSON. They are both base 64 URL encoded. They are joined with a dot. They are passed to a hashing algorithm or an encryption algorithm with your secret key. A signature is formed. That signature is formed. If you pass me your secret key, the way this encryption algorithm works is once you have this your signature and you pass in that your secret key to the validation function of this, it would validate whether it's true, whether actually this secret key was actually what was used to sign this signature. So once this is done, you base 64 URL encode it, and then you just join everything together. This URL encoded, this URL encoded, this is these two strings joined together and pass through this function included. That is what JWT is. It's actually very simple. It makes use of what we use in our daily lives. Use JSON, base64 URL encoding, and the regular algorithms that we use. It is not some kind of, they didn't try to implement some kind of new spec. They just use what already existed, which makes the spec very nice. How does it work? So before we do this, I'd like us to check out these websites. Your JWT journey cannot be complete without checking out JWT.io, which is just a debugger on your browser to help you see your JWTs. So as you can see here, the green parts are, can you see my screen? Reactive, you can see my screen.
Yeah, sure.
Yes, we can.
So the green part is the header, the white part is the payload, and this is the signature. So this is just a debugger that can help you you can use it to view what our JWT actually looks like. So see our key, let me just make the key fortune. Okay, the signature failed because it wasn't the previous one. This is not what was used to sign it. So I think I'll probably just go to the encoder. I think the encoder will show us what exactly is going on. Let's say fortune. I must make it big. So this is the secret. So any single time that I change the content of the JWT, like the name, I want to make the name to be about summer. The signature attached to it changes too. If you notice it, the header won't change. Why would the header not change? The header won't change because it is encoded. It's just encoded. There's nothing new added to it. So the payload will change, and because the payload and the header is being passed into the algorithm, the signature will also change. But it will change in a way that is mathematically possible to use the secret key used to encode it to verify it again. So that's the beauty of it. Not too complex. As you can see, it has claims, it has the algo, it has the type. So let's just see how fast we can go. The 1 hour session. So JWT diagram is just how your token lifecycle normally works. Generic. This is not a Spring Boot thing, it's not a Java thing. Just how it will work in the real world, even if you're JavaScript, Go, or whatever place you're coming from. How it usually works is a user will submit a username and password to the identity provider or an authorization server. Your single server can be both the authorization server and everything within itself, but it is checked against the database. Once we check and verify against the database that this user actually exists, which is authentication, we sign a JWT containing all the user claims, everything the user needs to log into our system, and then we give it back to the user, and then the client stores it in memory, secure storage or cookies. We say HTTP only cookies so that cookies are only transferred in HTTPS, so our cookies don't get over. The person normally we use your JWT can actually be sent from your cookies to can be sent as they can be saved as a cookie, so that when a browser loads up a page, it can send it out to. But I think in the modern, like right now, what everybody does is we actually just use it as a bearer token. So we attach authorization and bearer, and then just space the token, and we send it back to the server and we get a response. So server validation. The server receives the JWT, checks whether it has expired, check whether it matches the signature, then your request goes from there. As you can see, there's a small diagram here. I didn't use my hand to draw it, someone else's diagram. Yeah, probably should have referenced that. Stateless authentication. Okay. What does it mean? Stateless authentication, we're talking about stateful and stateless. So let's wrap our head around stateless authentication. Stateless authentication just means identifying the user without keeping track of the user in the database or keeping track that the user is logged in. So no session storage, meaning that no database, we don't have a data store or anything. So this saves us memory, which is why stateless authentication is good. Signature-based trust. We do not keep track of our identity or user identity or whether the user is logged in because we trust that the JWT has everything we need to verify the user. So we don't really need to call the database until we need something from the user. So once we have verified that JWT and we're sure that yes, this JWT came from us, we just let the user in. Then maybe when they get to a service that actually needs something from the database, the call can be made. So instead of the traditional session whereby every request we need to always check the database or the data store. Horizontal scalability. So new instances can be added behind the load balancer without resilience to node failures. Okay. Why is JWT secure? Victor, of that. Why JWT? Okay, sorry. Why JWT is secure? It guarantees and protects identity because of the signature attached to it, the digital signature attached to it. It has an immutable claim set. So if you change a claim, the signature changes entirely. So we are sure that someone tampered with it. We can be sure that someone tampered with it and not let the person in. Built-in expiration. So it always comes with an expiration. So JWT is not long-lived. You can make it long-lived, but your system will probably get compromised easily. So just limit how much time someone can use your access to. Algorithm agility. So it actually has there are a lot of algorithms you can use with the JWT spec. You're not just bound to one. So tomorrow, if HMAC, people say that HMAC can be easily cracked or you can just simply switch over to the other ones. So common JWT vulnerabilities. So this is actually very, very, people always think that JWT is secure within itself. Most of the time it isn't. And most of the time it comes from validation, lack of validation, or problems from the users itself. JWT does its best, but we could actually make mistake. So weak secret key. When creating JWTs, you are allowed to add a secret key. So if I take us back to this, we can see that you can actually use a secret key here. So even when that key, it tells you that that key must be larger than 256 bits. If you notice, we still have a signature here. But someone that really knows me, if I put my key as fortune, someone that knows me can actually guess. But the reason they tell you to use 256 bits is to solve this issue because 256 bits, I think, is the minimum entropy for HS256. 256 bits is 32 characters. I mean, 32 characters. That's how many bytes? 32 characters. So, is it 32 characters? All right. I think yes, 32 characters. So once you type it up to 32, it becomes one that is actually strong and has enough entropy to go against dictionary attacks or rainbow attacks or whatever hackers are using nowadays. Missing or over long expiration. So always keep your JWT to as minimum time as possible. Make it very, very low. Storage. XSS attack. So cross-site scripting, your JWT can actually, so I have a scarlet draw here that I just wanted to whip out so that we all understand this. So we have two main attacks that people normally use for these cross-site request forgery. So normally, this, imagine I had a malicious website and I was to attach this. I'll try to skip through this as quick as possible. So Samuel, you have 1 million in your bank, or you have so amount of money in your bank, and this is my account number, and I want to take that your money that you have. I want to take it. I know that you have money, and I want to take it. I tell you to go to this malicious website. You have an account with bank.com. You load up this my malicious website. I have an image pointing to bank.com. So the default behavior of a browser is that whenever it comes across a domain, what will it do? It will send a session attached with that domain. And if you store your JWT in this session or cookies in this session, it means that normally this attacker.com does not know, cannot read this your session, cannot get it. But because he attached this to your website, to his website, and the browser thinks that it's loading an image, but because of his default behavior, it does this, which is actually very valid in your bank API or something. This is how the bank usually transfer money. Maybe the bank.com is how to transfer your money. Use their API to transfer money. And then to take that session within that browser context that is mapped to www.bank.com, and then it sends it, and then money leaves your account. So how do you solve this? Don't put your JWT inside a cookie. Probably don't. And even if you do, I think Spring Security has a CSRF. So you send a CSRF token every single request. That should mitigate that attack. We have XSS. So XSS normally comes with when you don't validate data that goes to your backend. So yeah, when you don't validate data that goes to your backend. So imagine I was an attacker and I wanted to fill my username on your website, and I pass this in. Your backend will actually go through it and see it as valid because this is just a string. All the usernames. Maybe he wants to make a new friend and he's going to his Facebook, let me say his Facebook feed. You want to get a new friend, and he sees this my username. Once this is loaded in his browser, this part won't get rendered. What will happen to it? It will get run. So imagine if the thing that is inside here now is documents.send cookie, send everything that has to do with your browser. Just send it out and send it to me in my email or another server. So you can be compromised through this. So even if you drop your JWT in a local storage or in a session storage, it means that with XSS attack, they could actually get your user tokens from the browser context. Another example of this happening in a modern time is through extensions. So I have multiple extensions here on my screen. If anyone now was malicious and I gave them access to this web page, and this web page had tokens, reasonable tokens, they could actually steal it. So I think the way to solve this is you can use something called, you can actually sanitize these inputs to not let these inputs get far. And for your extensions, be very careful on the kind of extensions that you allow. Chrome tries, I think the Chrome store, they do their best to remove those things, but sometimes it just happens. Skipping JWT validation. So this is not one that I would say the user can make, but the libraries that you use can make them. So like JWTs don't always have to be encrypted. So if I put none here, if I put none here, this is valid. This JWT is created without adding a signature. You will see the signature part is missing. So a library, so imagine I was encoding with my HS256 and I want to get into your application. I just do this, set my token to null, and then I send it to you. But then your library that is passing the JWT sees the algorithm none and feels like, oh, this token doesn't need to be verified. So I'm just going to let it in. And then you could be compromised. This was an issue that existed before, but it has actually changed because most libraries use JWS, meaning JW signature. And to be very sure of it, make sure that your encoder and decoder actually explicitly uses an encoding. We're going to see what it means by explicitly. It has to, you do not implicitly let your browser, your library decide which kind of token it is. If not, this kind of vulnerability can happen to you because you have a secret key, meaning that you are expecting a signature. Most libraries, I think the Java libraries don't have this issue unless Unless if they're up to date, most of the JWT libraries have actually covered this issue. They don't really have them, but it's just something that we need to have. Best practices, I've already mentioned this: use high entropy signature by verification, use HTTPS, use long lifespan, and implement refresh token. So I'm not, like I said, I'm also an expert in creating enterprise applications, but refresh token is actually reduce your user experience when using an application. So fundamentals of Spring Security. Let's get to the Spring Security. So this is just this is not going to be a full Spring Security tutorial. I think my time is almost. We also need to be able to ask questions. So let me see how fast I can rush. Principal authentication. Principal is who you are. It could be a user. It could be a JWT. It could be a OCID user. It could be a OAuth2 user. So these are different extensions of implementations of user details class that we use in Spring Security. So if you authenticate with a JWT, your principal will actually be JWT. If you authenticate with OAuth2, it will be an OAuth2 user and the rest. Authentication is who you are. That is your principal plus your password plus your scope, your granted authorities. What is authorization? Authorization is what can you access. So this decision is made on this granted authority, which is the roles and permissions, as you can see here. So we have the security context. So if you want to be able to access the current authentication within a scope or your as you're coding, you use the security context. And the security context have a parent that stores it, which is a security context. So this is Java. Adding dependencies. So we want to have a full working JWT flow in our Spring Boot application. What do? So you need the OAuth2 resource server, Spring Security Starter, Spring Boot Starter Web. Lombok is optional. So JWT processing library. So we have the JWT and the Nimbus UZ. So JWT is actually very, very popular. I think a lot of us, if you have actually done JWT and you go online and you look at some tutorials, you will see JWT. JWT is good, but it only supports JWS, meaning that you can only use it for signature. You cannot actually encrypt with it. Spring Boot supports Nimbus. So anytime you're using OAuth2 resource server, Spring Boot adds Nimbus UZ. Why does it use Nimbus UZ? Because it allows for both signing, verification, and encryption of tokens. So you don't really need, anytime you're using JWTs in Spring Boot, you don't really need to start adding this again. Just add this OAuth2 resource server, which Spring Security is already integrated with, and you have the JWT encoder and decoder already. We're going to see how to use it. Here. Can you guys hear me?
Yes.
Okay. So this is just the. Okay. Thank you very much. How JWT authentication works in Spring Boot. So this is just a diagram or a flow. You first get your bearer token, that's a token. It gets sent to the authentication manager. So your authentication manager is a layer in Spring Security that it maps out which provider to send it to. So there are a lot of providers. There is the DAO authentication provider. I think maybe if you have done database, maybe authenticating a user with a database, you have actually used this. We have but for JWT, what we actually care about is the JWT authentication provider. So anytime you receive a bearer token, the provider manager will route it to the JWT authentication provider. If you actually log out your security, you will see all these processes, but that is for someone that wants to go in depth into it. The JWT authentication provider needs two things. It needs a decoder, which will be used to decode or maybe decrypt the token, and it needs a JWT authentication converter. So implicitly, Spring Boot will convert the JWT decoder to a JWT object, which you can use in your security context. But you might want a different approach to it. Maybe you want to do some mathematics before it gets to the, sorry for my English, sorry for my Chinese, because it's getting somewhere. So we could actually just, after it's done, after you use the JWT decoder and your description converter, it sends back this JWT principal and the authorities that it has decoded from the token. So this is just, I'm not going to go through this code and I'm going to look at it in my IDE, but this is, all you need is just security filter chain, which is default. If you want to override the default behavior of Spring Security in your Spring Boot applications, you need a JWT decoder being symmetric. This is for symmetric and this is for asymmetric. So if you have someone that's going to be dealing with public key or you want to know how public key works, there's a reference at the end, but this is just how you to look like, because this is Java and this is Spring Boot. They try to make it as easy as possible. You don't have to be, those JWT, extract claims username, extract, that thing used to tire me. That is the time I used to do it. You expose a JWT encoder being. So it's as simple as this. We're going to look into it in my code. You create a token service. Are you seeing how simple and elegant the token service is? We are not doing extract claims, your grandfather, extract claim this, extract claim. If you use JWT and you try to implement your own filters and start, very stressful. Spring Security already comes with JWT itself. So using an external library and you start doing the whole process doesn't really make sense. So this is just it. We take in authentication credentials. The authentication manager uses the user details service to verify the username and password, collects their authorities, sets the expiration dates, signs it with the token service, and we just send the access token back to the client. Think, okay, this is here. Can you see my IDE?
Yes, your
Yeah, very well. Your ID is coming out here.
Okay, so this is just the dependency we need. Normally this usually used to be Spring Starter Web, but Spring 4.0.0.2 they are demodularizing all the dependencies. So I think this is what I got, Web MVC. So there is Spring Security OAuth2 resource server. This is just for testing. I'm not really going to do tests. I know the scope of this doesn't concern tests. So this is just mainly this string. This is for the server, this is for security, and this is for JWT. So what's our first step? We configure our, I don't mind, this is the value of the secret key, which I actually added here. Forgive me, just rubbish I type out. And Java is very secure, meaning that if I try to actually run this without using the right, that's one thing. JWT, Spring Security it actually does a lot of heavy listing for you. So if I try to run this without using the right, this, we get an error. Secret length must be at least 256 bits. If you notice, the JWT.io browser allowed the debugger allowed us to be able to create JWTs, even though that our keys was not up to 32 characters. That is 256 bits. But Java will not allow it. That is how strict the specification was. It won't even let you begin to go that direction. So we just, so that we see that this is no magic. We have our security filter chain. We allow a route, that is a route for our login. This is a route that we don't want to authorize, we want to permit it. And then instead of adding the whole, there's something we usually do where you say add filter before. We don't do that. We just override the default OAuth2 resource server implementation and add your own decoder. We set up an in-memory details manager because I don't want to actually load anything in my database. It's just a very simple thing. It's my username, fortune, and password. We expose the authentication manager being. We create a secret key. The secret key is just basically that key that we had in our application YAML, and then we prescribe an algorithm, which is HMARC 256. We create a decoder and we create an encoder. 2 lines. See how simple it is. Very easy. The reference to the docs will actually be in this slide. So, and then we disable SCRF. So Spring Boot actually uses sessions by default. So we have to disable session creation policy and set it to stateless. Because we want to use stateless authentication, and we have to disable CSRF. So Spring Boot is, like I said, is a beast by default. So it already knows we can be hacked by using CSRF. So it just enables it by default. But in JWTs, we're not adding anything to the token. We're not adding anything to the cookies. So we don't really need this protection. So we disable here and we disable here. We have our authentication controller, our auth controller, which will just be, like I said, you have your authentication manager, you give it username and password. It goes to the, I think this one will go to which authentication provider? It goes to our authentication provider. Then we get an authentication object. We pass it to the token service or generate token. Let's see how it looks like. This is it. Is this simple? We get our current time. We set the time to now plus 5 minutes. We show it now. We show it to ourselves. If you are creating, I think if you are creating better systems, this link should actually be to your authorization server. But I'm just using self here. Don't have to follow me. I'm just using self here. We add a scope. I'm keeping the scope to just 3 letters because I don't want to make my JWT too loaded. And then I just encode. We don't have to do the whole extract claims. I'm very sure a lot of us have gone through that extract claims with username. This is the way Spring Boot have done it for us. So get in touch with the times. I don't know whether we have time to test it. Or we'll test it after. Let me still be done with the slide. I'm almost done.
All right.
So let me just.
Yeah.
So what happens if your token is invalid? So most of the time in JWTs, you're going to face a lot of issues could just arise up from nowhere. So how do we begin to trace these issues? If your JWT, if you get a 401 in your security, check whether the token has expired. If you get a 401, check whether you're actually sending the right token. Maybe someone has tampered with the token. So anytime you get an invalid signature exception, someone is trying to run something with your system. Missing token, always check whether authorization, whether you actually put it to authorization space for JWT. So make sure you are setting the right headers. I remember the time I was trying to use inter-switch payment service. Okay, I'll get to that. That is here. This debugger actually helped me a lot when I was using the inter-switch payment service. So with the payment service, they had the token. They would give you a token that you use to interact with their payments. So I think that day they were fixing some issues, and I got the token and I used it in my backend. But the test payments were not working. I was asking myself why. I had to come to these websites. It's very convenient. JWT.io. I tested it out. I saw that the time was not really changing. So the time was like 2 days ago. So I think during maintenance, they were not really issuing any new tokens in the future. They just stopped it. So any token you get was actually expired. So when I checked, I realized that the fault wasn't from me. And I think after a day or two, when I tried to make a request again, after the system was up, the test system was up, everything worked. So personally identifiable information. In your JWTs, do not add user information. Do not add the user email. Leave it to an ID, leave it to permission, leave it to roles, leave it to every single thing you need. Do not add in passwords or financial information. If your system requires password or financial information to be sent through JWT, encrypt it. That is when you know that your system needs encryption. No more signing. You don't need to sign anymore. You need to use JWE, not JWS. So JWT is for identity and authorization. Do not use it for data storage. Do not pass in all the claims in the world inside your JWT. Try and keep everything minimal. So refresh token. We have already looked at this. It's just basically using a token, a more long-lived token, to be able to get a new access token, because our access token is short-lived. In most of the applications, we usually see it, but we don't really understand it. In our social media applications, you can actually make a request. You're actually using the application, but for some reason, in a week, if you don't come back, it will log you out. But if you keep coming back to the application, you could almost stay a month without you logging in again. This is refresh token and access token. It originated from, I think, the O2 spec, and a lot of people, a lot of systems actually use it today. JWT in microservice. So for token propagation. So imagine this kind of architecture. Modern architecture is actually bigger than this now. So imagine we have auth service, service A, service B, service C, the shipping service, and we need to pass an identity all the way down here. JWT is the only thing that can help us do it. If we're using session, we need like an external data store somewhere here, and we have to be, all of them might have to check with it if they will need to identify the user. For JWT, we don't really care. We just transfer it, and as long as the API gateway have validated it, we are sure that the token that is being passed to us is safe, and we can pass it and use the subject inside it. So advantages of JWT and limitations: for statelessness, for portability. Limitations: revocation. So JWT will not only give you the ability to sign out the user. So if the token is compromised, it's probably going to stay within your system until it has expired. Payload size can grow, so be very careful with what you add in your JWT. The more tokens you add, the more bigger your JWT gets bigger. The more claims you add, the more JWT length size you get. Conclusion. So in the last class, I think the last lightning session, they taught us about OWASP. Make sure you use trusted. I think the ladies, they took us over, they mentioned this. So make sure you use trusted libraries. Don't use a library that has CVEs and can be exploited. Like I showed you with the non-authorization, with the algorithm non, that someone can actually use to take control of your system if your library doesn't validate well. So validate your header and payload claims. Very important. Choose the secure algorithm. So if you're using a single server, probably use HMAC. If you're using microservice or using microservice, don't use the secret key anymore. Switch to a more asymmetric encryption, that is RSC and the rest. And do not implement your own cryptography. So all those, your JWT, and you create your own authentication filter, try as best as possible to not do it. Do not roll out your own crypto implementations. And if you can use an identity provider, it's best. Do not implement if you don't have the technical know-how. So this is just me. In case my helper is on this call, I'm a graduate of Futo. I think John is on this call. No, that John is on this call. I'm a graduate from Futo, and I'm currently unemployed. And if you're looking to me for these projects, you can reach out to me on my email. This is advert. You reach me on my email, you can see my portfolio. I think I'm on the NAIJA-JUG group, so you can reach out to me. Let's see how fast we can be. References. So these 3 references are important. If you want to know how the JWT works, you want to know the mass, the elliptic curve, you want to understand it to the very core, the first one, the handbook, is for you. If you're like me, I don't care about the mass, I just want to, how do I use JWT in Spring Boot? And what does the Spring Boot offer us when it comes to JWT? The second reference is for you. If you want to explore asymmetric tokens, so we have Dishon on our group. A very good friend of Dishon is Dan Vega. He does a lot of videos, and his blog talks about asymmetric keys. So thank you very much. Thank you very much. I think I have 1 minute to say. Fine. Thank you.
Thanks a lot.
I know I rushed, but 1 hour I think it was too small for authentication. Authentication is a bit of
It's all good.
rush.
It's all good. You did wonderfully well.
Okay, I will. I will push
Wonderfully
the
well.
code.
Yeah, sure. Thank you. Yeah, thank you very much, Ikechukwu. I really do appreciate. I don't know if our time still permits us for questions. It's almost up. Yeah, but then whoever has a question can go ahead. I'm not sure it will be ending immediately.
Okay. So any questions?
Anyone with question?
Not to be giving me emoji. You can ask question. You ask. You can also ask.
Okay, how do we get access to the repository and the PDF? And
Okay. This
first of
slide.
all, thanks a lot. It's a very insightful one. Some of us use this day in, day out. When you want to test APIs, you have to get from your response this authentication bearer for as an API. Like you have to check for you to test subsequent APIs in the system. Yeah, you have to go and check this auth bearer. Once you're able to log in the response of the login API, there is this auth bearer you just spoke about for systems that are making use of this thing. You see it as auth bearer, then the token, then you copy, then you paste in your Postman to make any subsequent calls to other APIs in the system. I use it day in, day out, but I don't really understand the entire flow. And this your lecture really educated me a lot. And I appreciate having access to the repository so that I can go over the flow again. And
on this slide, I'll add the link to my GitHub. So I'll push it to GitHub. It's on GitHub already, so I'll just attach it as part of the reference. Is that okay? So you get the slide and you pick up the link from it. And the other references too can also let you learn more about JWT.
Thank you very much. I also do well to follow you on LinkedIn too. So we are very honored.
No problem. Problem. Get good fortune. I will share in the slide everything is here.
All right. Thank you.
Any other question for the end? Any other question? No, you can answer. You can ask.
Okay. Thank you very much. Just a quick one. So, for every technology that exists, there are always alternative options and maybe alternative technology. So I don't know if there's any other popular tool that also solves the same problem as JWT.
Okay. Obviously, there are going to be alternatives. There might be a lot of alternatives, but I think it's not. They don't just have. There are different ways of authentication that might have to do with tokens. I think there is the basic authentication too. There are lots of alternatives I might not know, but I think JWTs are very popular. Sessions and JWTs are actually the most popular. So I think that's where people mostly focus on. But if you can actually understand it, I'm sure that any other kind of alternative that you come across will probably be able to scale through. I don't know what kind of authentication. I don't know whether they use JWT in JSON RPC and some of the other protocols. They probably do, but I'm not sure. Like I said, I'm not really explored enterprise level applications. But from what I know, the most popular forms of authentication are usually sessions and JWTs, and this is what you see in a lot of places. Obviously, there are other alternatives, but I think the most popular ones are okay. The reason they are popular, they are enough for everything. Is that okay?
All right, thank you.
All right. Any more questions before we go?
John, I see you. Hi, John Dave. Yeah, my boss with that.
Any more questions? All right. Okay. In the absence of no question, let me chip in a bit, just a little question. I want to confirm what you said before. You mentioned about using the cookies. Do you think it is actually safe to use the cookie? And when do you think it is not safe to use the cookie for the JWT?
So I was explaining with this, let me just go back to this escalator. So I was trying to explain here that using cookies will actually make you susceptible to this kind of attack, cross-site request forgery. I said that I wanted to steal Samuel's 1 million in his account. And if I was to add this to my website, this domain is not actually on this myattacker.com, but I could add it. The default behavior of the browser is to send cookies mapped to a domain. to the domain when it's being requested. So whenever the browser will try to load this as an image, but in the process of loading it, it's going to attach sessions, even though it is actually on another person's website. You get it? So the moment it does this, it sends these sessions, you are compromised. So JWTs can actually be everywhere. It can be in your cookies, it can be in your headers, it can be in your params. But I think why we have actually moved to using it in mainly headers, or at least bearer tokens, is because of we can fall into this kind of attack. So just if you don't want to fall into this kind of attack, just don't put your JWTs in your cookies. Just don't. I think cookies are small. Okay, cookies are okay. Your JWTs can actually enter your cookie, but just don't, so that you don't fall into this kind of attack.
All right. That is very good. Thank you very much, Mr. Ikechukwu. And there are some of us who are demanding for the PDF. Please, I posted a link, our community link. Please do well to join the community, our WhatsApp community, so that you can be able to get the materials when it is pasted, because we are going to paste it right there after the section. The link is in the chat section. Just go to the chat section. You can see the link there. Then just click to join the platform. Okay, with this done, I will say a very big thank you to Mr. Ikechukwu for a job well done for demystifying this very topic. You want to
apologize. I want to apologize. I wasn't able to test it, but I just hope that I did justice to the topic. At least we have a basic understanding of. We have not seen JWT as anything magical. We actually understand that it came from somewhere. You know, I didn't properly test it. I'm supposed to actually go through the whole testing phase and show the implementation, but because of time, I will upload the repo and I will try and document it and even add comments so that anybody that wants to exploit in Spring Boot to actually understand. Victor, sorry for cutting you off. I just wanted to just make it clear.
That's okay. That's okay. If you might even want, we can make it a second section some other time, so you can just wrap it up.
Somewhere like that.
Fine too.
No,
so don't have anything. It can be part 2 of JWT section. So that will be fine too. It's okay. You did wonderfully well. I really appreciate this time, and you can as well share your I think your